Okay, so let's look at logarithmic function in more detail. Find the inverse of the basic exponential function y equals 2x. So for the inverse, we basically swap the x and y. I hope you remember that. You learned that as the last concept in the transformation function. Transformation unit. Okay, so basically swap these two. Then you have x equals to 2 raised to the power of y. And of course, we have to express y in terms of other variables. So there are two ways you can finish off this part here. I'll show you both ways. So one way there, one there, one here. Okay, to reinforce the concept of what we have learned so far today. So one way is you can move the base of 2, which is the shortcut method. You can move the base of the exponent to the other side as the base of the logarithm. So like this. Log of base 2, and then the exponent here drops like this. And again, if you're saying chain, it doesn't make sense. So you can do it the longer way. So base 2 as the exponent, the base for the exponent. So you are going to take the logarithm on both sides. In this case, with a base 2, and then bring the x down, and then bring the 2 raised to the power of y here. Now, I'm not going to repeat myself. That cancels out. So that gives you y equal to log base 2 of x. If you look at this, same answer. So it doesn't matter. Alright? So now we have this. What can we do? Of course, we can graph it. If you don't feel comfortable with this way, never mind. You can write that as just move the y to or move this to the other side. Y equals to log base 2 of x. Okay, so the inverse of the basic exponential function is the basic logarithmic function y equals to log base 2x. So this is not on your formula sheet. If you want to memorize that, great. If not, never mind. As you can see, it's not too hard to derive that, to figure that out. Okay, so let's do something, because we have not done any graphing at all. Let's do some graphing here. Let's do this. Alright, so take out your graphing calculator. Let's graph this. So let's graph the first one first. Let's set up our rough table of values so that we are familiar with how to work things out. In case if for whatever reason your graphing calculator doesn't work, then we will use the graphing calculator to prove this, or to confirm that we get the right answer. Right, so let's start off with the exponential function that we just finished. So a table of value, x and y. Let's pick a few easy points. Let's pick x to be -1. So that means 2 raised to the power of -1, which is the same as 1 over 2. Then let's do 0 for x. 2 raised to the power of 0 gives you 1. And then let's do 1. 2 raised to the power of 1 is 2. And then let's do 2 here. 2 raised to the power of 2, or 2 squared, gives you 4. And then let's do one more. And let's do 3. Okay, 2 raised to the power of 3 is 8. Now quickly sketch this. -1 is 1/2. -1 is 1/2. Somewhere there. And then 0 is 1. I hope there's nothing surprising. Remember the y equals to abx format. So y equals to abx. There's no other transformation, so our a value in this case, which is the number in front of 2, which is 1 in this case, tells you that the y-intercept is 1. Anyway, so next point, 1 and 2, 1 and 2 right here. Oops, wrong color. And then 2 and 4, 2 and 1, 2, 3, 4. I hope this is a review for you with regard to what an exponential function looks like. 3 and 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And then remember, we have an invisible line, the horizontal asymptote. So arrowhead, y equals to 2 raised to the power of x. So this one here, let's do green. So x and y. So you can plug this into your graphing calculator. Okay, so let's pick a few points. Let's do -1 here. Plug that into your graphing calculator. This one I'll walk you through because I want you to see something. So log base 2, -1. Log base 2, and then -1. Watch this. Error. There's nothing wrong with the set of your graphing calculator. So this is error. What about 0? Try this. You see that it is also error. What does that mean? We cannot take the log of a negative number and 0. Let's do 1/2. So 1/2 would give you -1. Okay, and then 2, that would give you 1. Because if you look at this, log base 2 of 2, they cancel out. That gives you 1 because you have 2 raised to the power of 1. Anyway, so let's do 4 here. That will give you 2, 8, and 3. So if you plot this, so 1/2, -1, 1/2, -1, and then 2 and 1, 2 and 1, 4 and 2, 1, 2, 3, 4, and 2 right there, and then 8 and 3, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3 right there. Okay, you probably know that I try to stay away from the y-axis. Well, now I would like you guys to see it yourself. Let's plot all this. Oh, before that, let me just label this. Y equals to log base 2x. Move over here so that you don't get these two mixed up. Okay, so let's quickly graph this. Clear this, clear. So let's do the graphing. First one is 2 raised to the power of x. And then second graph, we want log base 2. So math, second last option, base 2 of x. And before that, go to zoom. We want number 6, the standard grid. Now here we go. So you tend to think that there might be a horizontal asymptote. No, it goes all the way down if you check out the table of values for the red graph. Okay, if you change the setting, you will, well, let's do this. So let's do this. Second window, you can change the value to 0.5. You don't have to do this because once you do that, the table of values would be in the increment of 0.5, which may be annoying sometimes, but anyway, I want to show you this. So clear, go to second graph, table of values. Okay, so your graph here would keep going down and down and down, but it will never touch the y-axis. It just go down, even though it didn't show you that. This is the confusing part of your graphing calculator. Same thing here. When you look at this, you tend to think that it's touching the x-axis. No, as you all know. Again, check this out. Second graph. Look at all this. It's getting so close to zero. And for your log graph, you will find that you cannot take the log of 0. You cannot take the log of any negative numbers. So that's why your graph will just go all the way here, but never touching the y-axis, and this would not be anything here in the negative territory for negative x values. And one last comment is the line of refraction. So I'll just do this one here. Line of refraction is when y equals to x. You should see this. Sorry, it's off a little bit, but you know what I mean. So if you look at this, these two are mirror image of each other. Okay, now let's compare them. So I'm too lazy to scroll it up and down all the time, but make sure you have your graphing calculator with you. Then it would be handy and easy for you to understand. So now if you look at, well, we have done something like this before, so I'll quickly go over this part here. Let's look at this. For our exponential function, the blue one, so domain is axial. X could be anything. The range, that's an invisible line. Y has to be greater than 0, cannot even be 0. So y is greater than 0. And the x-intercept, nope, none. Y-intercept, as we figure out shortcut method, the a value, that gives you 0 and 1. Okay, asymptote, there's an invisible line here, right here, for the blue graph, for the exponential function. So y is equal to 0. Okay, so let's look at green graph. The new stuff, logarithmic function. Domain, this green one would never be touching the y-axis. So x has to be greater than 0. Remember this. You cannot take the log of 0. You cannot take the log of a negative number. Next, y values obviously all the way from negative infinity to positive infinity. It goes slowly here. There's no horizontal asymptote. It just goes slowly up. Okay, so y e r. This should not be anything new, even though this is the first time we compare the graphs of exponential function and logarithmic function. But remember, when we talk about inverse, you flip this, x and y they flip, x and y they flip. Okay, and then x-intercept here would be 1 and 0. 1 and 0. Have a look. We didn't do 1, but you can try that. And then y-intercept would be none. Last but not the least, asymptote. Well, there's an untouchable line here, or is out of boundary. So the green graph here would never be touching the y-axis. So that's the asymptote. X equals to 0. So you might want to, oops, jot this one down here. Something that I already mentioned, you cannot take the logarithm of 0 or negative number. You can only take the logarithm of a positive number. Alright, so before we do more examples, let me quickly brush up your memory because there are lots of new stuff that you learned today. Hopefully you are not overwhelmed. So recall that if you have something like this, log base 2x equals to y, you can actually move the base of the log to the other side and make it the base of the exponent. So that means you have, after that, the log will be gone on this side. X equals to 2 raised to the power of y. Okay, so keep this in mind. Then the rest of the questions here on this line would be a piece of cake. Okay, so solve for x. What is this number? So let's do the same thing. Take the base of the exponent, move it to the other side, and make it the base of, sorry, take the base of the log, move it to the other side, and make it the base of the exponent, and turn the number into an exponent. So this. So after doing that, the log will be gone, and then you have x, the 2 becomes the exponent. Now that's easy. Take the square root of both sides, so that means x is 3. Well, you may remember that every time when we do the square root, we have to put down plus and minus. Okay, but if you look at what we just finished on the previous slide, we cannot have, well, I know I just mentioned that you cannot take the log of a negative number, but for the base here, it cannot be a negative number. Try this out. So let's do this. So you can do the positive one, but let's do the negative one. So clear all this. So log base 3 of 9, that gives you 2. That's what we have here. Log base 3 of 9 gives you 2. Let's do the negative one here. So log base negative 3 of 9. Guess what? Error. Because we cannot have a base of negative. Alright, so just keep this in mind. So therefore in this case, we cannot have a negative base. So that means in this case, the only answer is x has to be 3. Okay, let's do several more. Solve for x. Okay, so move the base of the log to the other side and turn it into the base of the exponent. Then the log will be gone on that side. Okay, so that means, oops, wrong color. So move this there. So that means x is now 64 raised to the power of 2/3. Okay, you can punch this into your calculator, but I want to sort of review this with you guys. What does the 2 and the 3 mean? The 1 on the top means exponent, so that means you have 64 square. And then the 3 on the bottom means the root, so that means you have a cube root. If you find this a bit confusing, put the brackets around, that's fine. So if you simply punch this in your calculator, you would get 16. Okay, let's quickly do this one. Wrong color. Let's quickly do this one. Alright, so move the base of the log and turn that to the other side, turn that into the base of the exponent. So raise to the power of negative 1 over 4, and then left hand side, the log is gone, so quickly punch that into your calculator. So that will give you 1/2. Alright, so I hope you don't find this too bad. Let's do several more. We did something like this earlier on today, so again, there are two ways you can do that. You can do it algebraically, or you can cheat a little bit by simply punching this into your calculator. Let's do it algebraically to reinforce the concept. So if you remember what we did a few slides ago, we need to set this equal to something. So let's set that equal to x. So move the base. So I hope it becomes your second instinct now. So now by moving the base of the log, you have 1 on the left and then 6 raised to the power of x on the right. And if you look at this, 6 raised to the power of what gives you 1? Well, obviously x has to be 1. Okay, so now next one. Well, I hope this piece of cake. Remember what I taught you guys before? This would cancel out. So anyway, let's play dumb. Alright, so if you look at this, same thing, move the base there, and that will give you 25 equals to 25 raised to the power of x, and of course in this case x needs to be 1, or as I mentioned, this one may not be obvious, that obvious. So if you look at this, this is basically raised to the power of 1, and then because the base of the log is the same as the base of the exponent, if you do it this way, it would be a bit more obvious. They cancel out, so that means the answer is 1. Okay, let's quickly do the last one here. This one, let's do it algebraically first. Right, so if you look at this one may seem a bit confusing, but never mind, we can just focus on this part first. So let's do it on the side here. So set this thing, just this, equal to x. So if you do this, so log base 749 equals to x, and then do the same thing, move the base. So 49 equals to 7x. Oh my. So 7. Oh my, that's annoying. 7x. Okay, so I hope you can see that 7 squared gives you 49, so that means 7 squared equals to 7x, so that means x must be 2. So now that means this whole thing is equal to 2. 7 squared gives you 49. Of course, you can simply enter this into your calculator. So let's wrap up today's session with a few special cases. We actually touched on some of them already. So the log of 1, no matter what the base is, will always equal to 0. So let's use some examples to illustrate that. The log of 1, no matter what the base is, let's call this base, would always equal to 0. Why? If you use the same trick that I have been showing you guys, move the base, So that means it becomes 1 is b raised to the power of 0. Because when the exponent is 0 for any number, it's always equal to 1. Like this. Example here. You can have 2 of 0, that gives you 1. 10 of 0, that gives you 1, so on and so forth. Okay, so second thing here, if the argument of the log is equivalent to the base, it will always be equals to 1, like this. Like this. Log whatever the base is, which is the same as the number that we take a log of, that will always be equal to 1. Why? As I showed you guys here. They cancel out. It doesn't give you 0 because we can write down b raised to the power of 1 here. This is gone, so the exponent becomes the answer. If you want, try out a few examples yourself. So let's do log base 5 of 5. You can try this on your calculator. So that cancels out, that gives you 1. And then, okay, last thing may not be so obvious. If a power has a logarithmic exponent, and the base of both are equivalent, something like this, the power will always equal to the argument of the log in the exponent. So in this case, if you plug this into your calculator, this would cancel out, and that will give you 13. Look at the example we did here from above. That, well, this point is a bit trivial, but have a look. So if you look at this, that would cancel out, and this will give you the answer. I know it may not ring the bell, make any sense to you. You know what? You can use a graphing calculator as one approach, or solve it algebraically. So that's another way if you don't want to memorize this, or if it doesn't make sense at all. So this is not my notes, but have a look. I don't know if that makes sense to you. Alright, so you might want to try out these questions. Have fun.